what we're doing today is I'm running the Swiss lathe. I'm taking down a job and I'm adding a new job. The screws for our knives, we're totally out of right now. We have like 0, so I have to have them done today. Pretty easy setup, so I just want to bring you guys along with the setup. And I figure now it's an awesome chance for me to kind of brag on these screws and bring you guys along with the journey of like how I quality check everyone, how I make sure they're perfect, how I dial in the sizes, and maybe throughout I'll just kind of banter about why I like to make them, why we don't buy them, and things like that. So yeah, the first thing we're going to do, had a very successful run the past few days of making these. The carousel's working awesome, but these guys, because they're so light and flat, they like to just suction cup themselves there. So the quantities in the bin is not what I care about right now. I know that these are all good. So all I'm going to do basically is consolidate them all into a bin. They're so suctiony. And then after that, these will get ultrasonic clean, washed and dried, and then they're ready to be anodized and then assembled. So as I was making these, I did constant quality checks on the diameters and the threads and everything. And once the lathe is warm, which doesn't take too long, man, they last for a very long time. So I made 400 of these, which is 400 dives, obviously. Good, last me for a little bit. And now I'm gonna have to make at least 700 screws because there's 7 screws per one knife. And that's 100 dives, which at today's production rate, that's not gonna last us very long. So at least 700. But because you need 7 per knife, the run is just so much longer. Okay, so I got them all in here. So this is our lock bar stabilizer, which has a Torx pattern machined into the end. And this goes on the inside of the handle. So they get mounted right there on the inside of the handle. And what that does, as I'm all oily now from the Swiss, if that wasn't there, then when the person's unlocking the knife, they would be able to overbend it, and that's terrible because we have a very set bend ratio there, usually about like that, and that creates a rigid stop so that the ham-fisted user can't just overbend it and cause problems. So it becomes a very important thing for the longevity and the consistency of a knife so that the bend we put in there stays good forever. So yeah, now we have a ton of these. And I'll show you a little pro tip here. So we bought this little scale on Amazon. It's like a gram scale or microgram scale or whatever you call it. And this is how I measure them. Get a part counting version. So if I go to pieces and I gotta tear it with the weight of the bin, and I've already calibrated it. So you take out 25 pieces, you tear the bin, you put 25 pieces in there, and then you qualify it or calibrate it. But now I can tell 366 in this bin right now. Oh yeah! So that's epic. So 366. I'm on a 2 towel rotation here. I got my super dirty one and then my fairly clean one, and then this gets thrown away and then I replace because oil is just not fun. The other thing I'm going to do is I'm going to write down yesterday's production. So yesterday I made 385 screws, but we physically have 366, which means I made whatever the difference is in scrap. So I've been writing down my daily production here. So I go 366 minus 76, 86 minus 19 bad ones. And I'll put the bad ones in the red bin here. And then they usually just get thrown away. Yeah, put this guy back. Reset that counter to 0. And then set that to 0. Okay. I'm going to open the next program. To do that, I go into here. I go into 440 screw. I hit Alter, set it as main, yes. Loading, loading, loading. I'm using the same program as before, no need to change anything. All my tools, I'm 90% sure they're all the same, I'll check. That one, that one, that one. Yep, all the tools are the same. So what I need to change is I need to change collets and guide bushing. So I've actually got 3 things. So let's get the ones that we need. So I know from experience, can you zoom in on this one? It got a little mangled. I had a bit of an oopsie, but luckily the inside is still fine, so I can still use this. But this is a special size 1/8 from Hardinge. I'm gonna buy a backup. I'm gonna buy a second one. So I need that. I need a 1/4 inch main collet, 1/8 sub, and then I need a 1/4 inch guide bushing. Done. All right, so these are the 3 things that I need to install. Let's start with the sub collet because it's kind of easy. So I'm gonna blow the chips off the lid. I hope this video will be really cool for all the machinists out there and even all the just guys who think this stuff is cool, because I know from watching videos, it's fun to watch somebody work, to watch somebody like do something you've never done before. So I'm trying to provide that experience right now for you guys. And I get to show you how this all works, because this is really cool stuff. Okay, so the sub collet is right there. I'm gonna grab my tools. Tornos has this really sweet little cubby hole where you can hide all your day-to-day tools. So it goes this way. In there. So that's your sub collet with a part. There was a part in it, a halfway finished part. So the way a Swiss lathe works is it makes half of the part there. This sub collet comes in, it grabs it, cuts it off, brings it back over here, and starts working on the head of it. So there's always one part halfway done. And it's so cheap in material, you just don't care, you just throw it. So that's sub collet. I'm gonna blow that off in a second. I'm gonna add the 1/8 sub collet. Also got to change the ejector pin. So check out this assembly right here. This is your parts ejector. So there's a pneumatic cylinder right here that says on, off, on, off. And then if you look over here, maybe we'll switch places. You can see there's the ejector pin that comes out. So it opens up the collet and then it spits the part out into the parts catcher, which is right there. So this is too fat for the parts that I'm making, so I gotta change that out too. So, come check this out. So I made a bunch of different sizes here to do what I need. So I'm gonna mic that, make sure that it is the size I'm thinking of. Basically, as long as it's smaller than the head of the part, we're good to go. So, dirty towel. Calipers. Yeah, 166. The part is 1/8. We're good to go. So then, get my vice grips. I didn't worry about putting any sort of grippy device on this because I just use vice grips. It's fine. Oh, fail. That's why I have this handy dandy telescoping magnet. Very close. Oh, I made it from titanium. It's not magnetic. That's hilarious. All right, I can reach that. I think. Going in? I'm going in. Got it. Gotta be careful because some of these tools are so sharp and pointy. All right, that's the one I don't need. I made them from titanium just because I wanted to see a blue one. And I did make one blue, and it was awesome. So it's a metric M5 thread on the end, and just threads in, and then vice grips just kind of crimps it down. It doesn't have to be tight, it just has to not fall out. All right. Now we can put the right collet in. Okay, and these tighten to a dead stop, which is nice because you just make it tight, and then it's good. It very much sucks that oil does not evaporate. It doesn't leave the part until you fully wipe it off or clean it with chemicals or whatever, even soap. Whereas with coolant, you can basically just blow a part off and it's 90% clean. So oily, I don't like the oil, but I accept the oil. It is nature of the beast. Okay, that's that. The other thing I gotta do is I gotta take my little bin of like kind of one of each finished part plus some random garbage. I'm going to triple check and make sure that my head diameter, like this is a good part. 180, bang on. And then I've got to tune the grippiness of that collet. So this linkage right here, it's got a pneumatic cylinder. So that's clamped, unclamped. So when I put my part in the end, it's actually too tight in the unclamped position. So I take my 3mm Allen key and I loosen this little crush nut, which wasn't very tight, and then I unscrew this a couple turns. So I'm unscrewing this tightening nut. Still no. Still no, wow. Really? Something's weird. So what happened is, for whatever reason, my 180 collet and my 180 part are not going together. Usually collet's a little bit bigger. And it's just not going in, even with no tension on it. So it must have shrunk down, or the crash did actually cause more problem to it than I thought. So I'm going to get my gauge pins and feel out exactly how small that hole is. And yeah, let's figure that out. Gotta be careful with Swiss oil, because already I'm getting it all over the mill section. That's usually not oily. 180. Clearly no. 178. No. 175. Barely. Fits perfectly, 175. What the heck? The collet is smaller than it's supposed to be.
Oh shit.
And it worked fine last time.
That's not the one that crashed?
Yeah. I thought it was fine.
Yeah, we polished out the...
Or we stopped making screws when it crashed.
Yeah.
So we never tried it again after.
Yeah, we can open it up if we need to.
Be more of a bending operation than a...
Yeah.
This is the only one I have right now. Like, I should be ordering 2 more.
You polished the ID.
But the ID is fine. It's just I think the 3 went smaller. So they bent inwards or something.
Yeah, if we get the surface tape on a V block, we could like run it out and see.
Because it fits a 175 perfectly.
What does it need to fit?
180. So it's 5 thou undersize.
And it would fit 180 before. Like
it was bigger.
Yeah.
Yep.
So definitely compressed in.
Yeah, I don't like that.
We could push it out if we need to.
Yeah, we might have to.
All right, let me wash my hands up from these. And
even if we go like 1 pin at a time. Actually, I'm doing it right now.
Like manually stretching it out?
Yeah. How close can you get on this? I'll try to be steady. So this is now your pivot point basically, because these are all long arms. And I'm trying to stretch it and move it out. It does go. Yeah, so the hole size is because of the crash that we did, it's 5 thou smaller than it's supposed to be than it was before. So we can actually bend it like that. I know Angela is so cringing right now because it's not good for the gauge pins. And I know that, I am aware. Use a crappy drill bit or something.
yeah.
So we should bend it back?
Yeah, I think that'll be fine. Not ideal, but sometimes you got to be creative and sometimes you just got to get it done.
All right.
So if we held it somehow like
Yeah.
easier than just your hand.
We don't want to go too far in any.
But yeah, you're moving it quite a bit. Like
Yeah.
it won't take a lot of that.
Be nice to be able to run this out on a V block.
Yeah.
Next shot, we'll set that
Let
up.
me check a 180 now. I can see it's bigger.
Almost.
180 fits now like a glove.
Okay.
So let's go bigger. Let's probably give it, I don't know what their oversize is. 183? Because when they make the collet, they constrain it to like standard and then they grind it to 180, but they want it to relax bigger because you want to be able to grip bigger onto your part. So this is a 183, a little bit more.
All that downhill mountain biking.
Yeah.
Finally coming to the use.
It's like your handlebar. There you go. 183. Let me try 182.
What size is going in? 180?
180.
Yeah, it's going to be perfect.
Let me try 181. Just one more time. Even that's kind of snug.
Yeah, still more.
But it's working. It's
right?
working, yeah.
Yeah, having it in something.
Like we can put it in the vise with a V-block.
Yeah, I just don't want to. Yeah, with the V block should work.
Yeah.
Don't want to crush that tube at all.
Right.
All right.
Yeah, we just need a little bit more.
Yeah. Feel like I'm gonna break these through a bit.
What if we have our... Let's try 183. Oh, like a glove.
Perfect.
And bigger is fine because the machine's going to clamp it.
Yep. Not even be worried about it sticking when it clamps.
Sweet.
We'll see how it goes when it gets in there.
What are you worried about?
Once it compresses again, that it's going to stay compressed.
Oh,
so
yeah.
We got to test one and see how it goes. Worst case, we could just open up the ID.
Yeah.
We have to. Shouldn't have to though.
Sweet.
All right, try that.
So that's a lot bigger.
Works.
185 goes through. 186 has resistance. 187. You can tell it's tapered now,
Yeah.
but that's fine.
But it should work.
So yeah, like you said, after a couple parts, after a couple clamping cycles, we'll check it. But I mean, they're spring steel. They're made to move. Okay. Well, now we can assemble it again, get it going, and now it should work. That was our problem. And I got my screw right there. I like when something actually makes sense eventually. So this is a perfect example of why you got to be flexible. Like nothing always works exactly as you think it's going to be. You know, you got to be creative. You got to figure out a solution. It's impossible for me to wait another week or two for another collet to come in. So I'm going to make this work. Who cares? If I had to, I would make an emergency collet. I would machine it myself out of a smaller one or something. But yeah, it's good to be nimble. So I've got my part. I could use a gauge pin for this too. Now it fits easily in there. I loosened it off so much before. Put my part more. So I'm adjusting the clamping tightness here. Not yet. Not yet. Getting there, okay. And you can feel this, it's like an over-center cam kind of thing. This guy's moving easily and then I can feel it gripping the part and then I need to go a little bit tighter. And in training for this machine, I learned it's just through feel. I basically want to be able to move this thingy with difficulty, but it's possible. Perfect. So now I can tighten down this little crush nut. Doesn't have to be tight. All right. Okay. I'm going to pause, take a mental break, make sure I'm doing everything right. Did that, I did that, I did that. This guy, can you see right here, there's the lights turn on. These are position sensors. So it's like measuring the piston inside of that. That's fully extended, that's fully retract, and there's a couple stages of lights. So I know it complains if it's mid, it says part ejector error. So I gotta try to keep it open. There we go. All right, then I can put this guy back on. We are done in there. Okay, that was one of the collets. Do the exact same thing on the main collet, and then the guide bushing as well. Okay, because this was 3/8 bar. So what I'm gonna do, I'm gonna go handle Z1. I wanna move this Z1 spindle. Stupid alarms. Gotta close all the doors, make the lathe happy. Okay. There now. Okay. There's an alarm right here. It says counter spindle collet fault. Because that lever arm, I left it in the wrong position. So the machine's going, ah! It's not where I thought it was. Let's see if I can clear it. Okay, I told the machine to turn it on so that it isn't now in the position where it thinks it is. Now we're a little bit happier. Okay, now it's allowing me to move the machine. So I'm gonna move the Z1, which is this whole main spindle here. I'm gonna move that out of the way. And I'm gonna move it way back. That's all the way, perfect. I'm going to, in manual mode, if you look over here, there's a side button. This is your two-hand dead man switch. You gotta hold that, and then you gotta push this for 3 seconds, 1, 2, 3, until the thumb light turns off, and then I can open the main collet. If you look in the machine, I'll show you what it's doing. This is how it's automatically doing it. just like we were doing manually. So I want it in that position, open. And then I can come over here to the bar feeder. And that is bar feeder, not barf eater. I can, what am I doing wrong? Oh, the door's open. There's so many little like rules to this machine that nobody tells you about. You just gotta trial and error your way to figure it out. Those doors have to be closed. And now I can move this. It's got a distance measurement. Your blue is your bar. I got 51 inches left, 49, 37. So I'm physically moving the whole bar back. Like when I first got this machine, I'd never really seen somebody use this. So maybe we'll get into it a little bit. Okay, now the bar is retracted. I can get in here, I can open the door, lights turn on. Collet's open, so just exactly on the same as the other side. Give my 2 wrenches. Changing from a 3/8 bar down to a 1/4. Put you there. 3/8. Grab my 1/4. Put her back in, triple check. Sometimes chips get kind of stuck in here, but I think it's pretty clean right now. Put it in, put the nut back on. It's pretty quick. It's kind of no big deal. And there's, other than this guy, there's no adjustment, but I will do that. So after having done this, I've had this lathe for, I don't know, 4 months, 5 months, something like that. I've been using it a lot. As far as any advice goes, I mean, triple check everything, even make checklists. Like, I'm kind of going off a mental checklist and I'm like, oh yeah, don't forget about that thing. Very soon I'm going to start having written instructions for how to do all this so that I can now share the responsibilities with other people. Checklists are huge, don't mess up. It's fairly logical if you know what you're doing. Yeah, just go slow, be careful. Actually, here's a good tip. My friend John Saunders told me about this. He was touring a shop and he's going to have video of this. But he saw one guy operating a lathe that was wearing a yellow safety vest, like a road worker vest. And he's like, what's up with the vest? And the owner of the shop was like, oh, you don't know about the vest thing? Okay, the vest thing is if somebody's wearing a vest, leave them alone. Don't talk to them, don't touch them, they're focused. The vest is like my, please don't bother me right now thing. So I might actually integrate that here because when I'm focusing, I don't want to leave a wrench in there. Like I've got a collet right here. If I forget that, it might get ruined. You need your brain space in here and it's so easy to be interrupted or to like get distracted or do something else. So yeah, I might get some yellow vests.
I think that's a really good idea.
Yeah, and I mean, it's not a rude thing. It's just like, guys, I need to focus. Like, and this is me non-verbally telling everybody, like, just not right now. Trick is, don't abuse it. Don't abuse the yellow vest and just leave it on all day. All right, this collet's good. I can put it away. The oil travels everywhere. It's here, it's there. You gotta keep it contained. Okay, guide bushing left, adjust that thing left. I'll adjust it now. The bar that I'm getting is precision ground. Perryman titanium is I think where I get it from. Very, very bang on size. So what I'm gonna use is I'm gonna use just a regular old end mill as my gauge. Let's double check the size of it, just so we know. Boom, 1/10 under, which is almost exactly what my bar size is. And the adjustment of this collet is not a big deal because you're just open, closed. It's adjusting the guide bushing that gets very tight. So I'm gonna put my little checking gauge right in there, and I'm gonna move this, and as you can see, there's no way I could even do that. So this has to be loosened quite a bit. And of course you drop your tools and you drop your ejector pins and Everything in the Swiss is kind of tight. But that's what I really like about this Tornos. I mean, this is not an advertisement for Tornos. I mean, I paid real money for this machine. But of all the machines I looked at, this is very bright, it's very open, I have room to work. It seemed like, and I've never worked on any other machine, but it seemed like a lot of the other ones are much tighter and seemingly annoying to work on. So again, I'm looking for that over center cam, that little click. There we go. A little bit tighter. A little bit tighter. Too tight. Perfect. Tight. Take the end mill out, obviously. Time for guide bushing. Now the guide bushing, it's a hardened steel outside with a carbide pad thingy on the inside. So there's actually a carbide tube in there. And what the bar is doing, if this is your bar, it's constantly sliding through. Well, not sliding, just moving forward and back. So sliding but not rotating, because the guide bushing rotates in RPM with the main spindle. So you're constantly shifting the workpiece back and forth, and any slop in here is going to make an oval part. It's going to make a weird sized part. So with the threads, and I'll show you the adjustment real quick, you adjust it until this like scrapes almost on the actual bar diameter that you have. Okay, I'm done with these. Done with this. Done with the screw. Going over to this thing, and I think this one. So what this guy is, if you have a bar in there, you can still add this. Switch spots. This slides in there, and the little grippies grip into pieces inside there. So you kind of rotate until you find them. Got it, and got it. So I'm undoing 2 set screws basically. Done. Now I can hold the black one still, and I can move the silver one to unthread the guide bushing. And yeah, I see it coming out the front. So it should be unthreaded now. If you look over here, ta-da! This is keyed in place, so it's rotation specific. But yeah, now this guy's done, I'll put the next one in. Make sure it's clean inside, not a lot of chips or anything. Ideally no chips. Get it in. It's a little tricky to thread it because your arms aren't long enough to do that. It does come with this little magnet adapter that I'm still sort of getting used to. I think all it really does is it keeps it from falling out. But I think it'll help. It'll let you get that first thread in without pushing it out. And it worked, because I can see it move back. There. Don't forget to take it out. Okay, so now it's in, it's tight, it just needs to be adjusted properly. Next thing we gotta do, okay. Over here, so this is the bar feeder. There are 3 bars right there staged. to be put in. There's one still in the system. So I am going to unlock it. So if we check that out, there we go. It's extracting the bar right now. Now there's a problem. And the error for having the doors open is servo motor fault or something like that. It's like, that doesn't tell me anything. Okay, I click the open button. It's going, yeah, so it's clamping the bar. It's pulling out the collet. There we go. And now this channel opens up. Now we should be safe. Take out this bar. Boom. So that's what I did not finish machining from that last bar because I'd made enough parts and ran out of time. The oil in the bar feeder is different than the oil in the Swiss. It's like heavier and more of a hydraulic oil. Also gross. Even grosser, actually. Okay. One bar down. I'm obviously not going to be machining these ones, so I'll take these ones out and wipe them off. Yeah, I'm done.
Did it work?
Oh, it worked great. Okay. So this is the pusher rod, and what happens is if this is your bar, this is a collet right here. So the bar gets shoved, or the collet gets shoved into the end of the bar. But that's for a 3/8. And they've got a nice little quick release spring-loaded pin in there that I can pull out. This guy comes off. Next one comes on. Here's my 1/4 inch diameter. Put it back on, line up the two little thingies. Come on. And then put the pin back on. That's it. I think that's it. Okay, so now I need to load new bar. I need to adjust the guide bushing. And then I think that's about it for setup. So we got our material storage here. Write it very clearly. I want 1/4 inch titanium, which is these guys. We have already turned a big chamfer on the end of these and cleaned them. So I'm just going to grab a couple of these. I'll grab 4 to get this started. Six-foot bars are kind of long. Okay. So I'm lining up one of them right at the end, and then the next one, and then the next one, and then the next one. Okay. I've got to teach the bar feeder not only the bar diameter, but the part that we're doing. So diameter is not 375, it's 0.25. The part length is okay. So the part length is 0.176 plus 0.008 on the front, plus 0.005 on the back, plus 0.0787 for the part-off blade. So 0.2677, 267. It's already there from the last one. So we got your diameter, you got your length, and then we are good. I'm gonna push this button. Here we go. Oh, so drop one bar down, and then I'm gonna manually load this, so it's pushing the bar forward. Now it's gonna come down, it's gonna shove the gripper, the collet, onto the end of it. Yeah, it should be good. And then I'm gonna move it forward. So I've got my pen in here, I'm just pushing the forward button until I see the bar come out of there. There it is. And then I'm gonna push it forward to the guide bushing, and I'll see if it comes out. It might get stuck. It came out. So there's a couple different ways to adjust the guide bushing tension. One way that I've grown to like, that a couple guys suggested, is if you get a shot this, maybe behind me here, you want that so tight that the bar barely moves through, but it does. So you want to be able to, with a rag or something, just push the bar out. But it's tight enough now that I can push it pretty easily. So I want to go a little bit tighter. So I'm just going to rotate the silver against the black. Just a crack. Yeah, that's pretty tight. So that might be too tight. Nah, maybe I'll go a little bit looser. And this totally becomes a feel and an experience thing, and I'm still learning. So I'm sure there's other opinions on this. And apparently with titanium, if you go too tight, it can gall the inside of the guide bushing, and then you get alarms and it's not sliding through properly. So I haven't had that yet. But you can start to imagine how important the actual roundness of the material is if it's got to slide through this thing that it doesn't want to slide through. So now I'm just tightening those two kind of pinchy screws on the guide bushing so it doesn't back itself out. We're good. So if I've done my job properly, that is everything that is necessary to swap over from one diameter to the next. Welcome back. It's the next day. I had to run last night, so I didn't quite get it finished. But this morning, I was able to finish everything up, get the lathe running, nice and good. So to recap what we did yesterday, I set up from a different job to a new job, changed collet, guide bushing, collet, adjusted everything, changed the bar loader from 3/8 diameter down to 1/4 inch diameter, and just made sure it was totally ready to go. And as you can tell right now, it's running hard. It's making 47 parts per hour. A screw takes 76.62 seconds per screw. So it's going great now. I've already made 190 screws today, which is awesome. So now I want to go through the measuring process, the validation, the way that I, make sure that the screws we're making are what I want to make, because tolerances are important. They waver, they thermal growth. When the machine's cold, it makes a different part than when it's warm. So yeah. So 2 parts just came out of there in our little parts bin. There's the 3rd one right there. So what I like to do is, this is another reason why the carousel is really good. I pulled 2 parts out, but this is the part that just fell in. This is the latest part. That's really the only one I care about right now. That's the one that just fell out. And if this is totally full of parts, but the last one is good, I know that they're all good because the machine is that consistent. If the latest part that comes out is bad, then I have to backtrack bin by bin by bin and see where the problem happened, whether an end mill broke or something. So what I do is I take my guy, I take, this is my go no-go gauge for Torx right now, and I push it in, I feel it, make sure it goes in nice and good. The coating has worn off on the bit there, so I know if it sticks in all the way, or if for whatever reason it doesn't, because this is the end mill that I use, a 20 thou 4-flute Lakeshore Carbide stub end mill that goes in that hole and mills out the Torxes. Maybe we'll have better lighting if you look in here. So this little guy goes in there and uses an adaptive clearing toolpath to clear out that Torx after I drill a pilot hole for the end mill to go in. And then there's 6 little detail dots that we use with a ball mill, just because it looks awesome that way. And there's even a chamfer on the outside of the Torx to make sure that that the tool goes in nice and it looks good. And actually that 2 thou chamfer glitters in the light just perfectly. So it has to be perfect. It has to look really good, and it actually adds some depth and some visual appeal to the screw, as well as being functional. So if the Torx passes, I know this is not like a proper go no go gauge, but the one that I found for a T9 is $900, just to be able to check if that thing is good or not. I'll probably get one eventually. I don't feel like getting it now. I've got more of this kind of stuff to buy. So if that's good, then I take my Mitutoyo mic. I'm gonna measure the head diameter. Remember, this is the latest part, so it's fairly accurate. I'm looking for 180, getting 180.05, that's good. I'm gonna rotate the part a little bit, measure it again, same, rotate, a little bit smaller, rotate, same, rotate, same. That's really good. So I'm literally, well, depending on where you're measuring, I'm either half a tenth bigger. Like, this is totally fine, totally within range. But 180 is my range. That's what I'm looking for. Yesterday, as I was adjusting the guide bushing, it's basically how tight, if this is your bar and this is your guide bushing, how tight the guide bushing is in there, and any extra slop means your bar can actually move around within the guide bushing, and it'll make an oval part. And I've noticed that on some parts. So this is oval by like a tenth or two, totally fine. So that check has passed. The diameter is perfect. I'm gonna check the head thickness. This one is surprisingly critical. I want 0.65. I'm getting 0.653. 0.653, I'm rotating it, I'm checking again, 0.6525, 0.653, so I can basically call it 0.653. 3/10 too big, let's fix that. So the way I'm gonna fix that is I'm gonna go into my tool screen, I'm gonna go down, I know from experience that my tool 510, Z, then I'm gonna click that wear, so I'm on the wear screen now. Already has some values because I've been messing with this. I wanna go 3/10 smaller. So in the wear, I'm gonna go negative 0.0003. Don't get this wrong. 0.3, and then I'm gonna put input, and it's gonna ask me, do you wanna go from +4.3 to +4? I'm taking that 3/10 off. And I always look and I always confirm, and I said yes, because if you miss a 0 or something, it's gonna screw you up. So yes, yes, yes. Okay, now from here forward, then it's gonna make those parts just 3/10 thinner. Now why that's so critical is because here, if that screw sticks up or down a thou, you really feel it. But when it's flush, oh man, it's like everything is perfect in the world when a screw sits flush. We especially notice it for the pivots. And we do have some variation there because not only the making the turn parts, but also milling the pocket in the handle. So there's a lot of variables at play to make it perfect, but when they're perfect, it's like butter, glass smooth, and it brings such a smile to my face. So that's why the thickness of the screw is important. After that, I want to check the threads. Now, currently, here's how I check the threads. So I have a thread gauge, a go, no-go male thread gauge, and I have a spacer that I made. This is the spacer that goes in the back of all of our knives. And I validated this thread with the go side. So the go side goes in just fine, not too sloppy, not too loose. The no-go side is bigger and it does not go in. It goes in less than one turn, then I can't get it in anymore. That thread is good. If the thread was too small, then the go side would not even go in. So I know that that's a good thread. This is a 3B thread gauge, which is one of the tightest you can get, meaning I know this whole thread is really, really good. So I'm gonna thread my screw into it, and I'm just gonna feel for wiggle. There's a little bit of wiggle. I'm okay with a little bit. And it goes down all the way, and I know it's good. If there's too much wiggle, I'll take the threading tool, which is tool 122, and I'll back that off just a little bit. But I'm okay with that. The other way you could do is you could measure this with a 3-wire set, and we've done that before. We do it for some of our other parts, but while we're trying to make the best parts in the world, we're not actually trying to meet a certain classification. These parts aren't going on airplanes. Like, nobody's validating our work. So I know that's good enough. It's great. It's a good thread. Yeah, so the cool thing about making changes on the fly, if you know what you're doing and you don't fat finger it and you don't miss a zero or something, is it will be applied the next time that tool is called, the next time that tool offset is called. So the next time it goes T510, it'll apply the new updated offset. If it's in the cut already for tool 510, it won't until the next one because it's already called the T line. So especially on a Swiss, because there's two parts being made at the same time, a change that you make on the sub spindle you see right away. A change that you make on the main spindle, it might even wait till the next run, and then it has to be transferred, which is another part, and then it has to be finished, which is another part. So you might not see it for 2 or 3 parts. So you got to be careful about knowing your offsets and how many parts need to flow through, which is why the carousel is so beneficial. You know, you set it to a 1 setting or a 2 setting, and you can make these changes. Next microscope I'm getting is going to have like an HDMI output.
What?
Yeah.
So like you're gonna have a direct in from there.
Yeah, so not only can you have a TV, but you can record it.
Yeah.
So.
That's not even fair.
Yeah. The other check that I do is I use my Leica microscope. This was actually a gift to me by a very, very cool guy. Like, what an amazing gift to give a machinist. If you don't know what to give your machinist friend for Christmas, spend $1,000 to get one of these. It's probably something that I would not have purchased on my own, but now that I have it, I want 3 more. Like, I can't live without this. I literally use it every single day. It's a stereo microscope, and we'll see if we can get some phone footage here. Oh, it's just tasty. So what I do is I turn on my phone and I line up the camera with one of the lenses. You can actually Inception style film this. And you just aim it just right. And look at that, I can see that at, I think it's 30 times magnification. So what that does is it lets me look at the chamfer, it lets me look at the centering of the chamfer. If the chamfer is off center from the Torx, that's bad, so I need to change the offset. It lets me look at the finish of the face, which is actually kind of gross right now. Like the kind of stuff that you can't see with your naked eye, but you put it under 30 times really good lighting and it starts to look like garbage. And I know that a lot of our customers are machinists or precision guys or nerds like we are, and you're going to be looking at it under a microscope. So, and I'm showing you that it's okay. So we want to create the absolute best products so that you guys are free to like micro check it, and you know, nothing is perfect. Perfect doesn't exist. If you think it's perfect, then you haven't learned the next thing that will prove that it's not perfect yet. I use this sticky tack that you use to like put papers up on the wall or whatever. You get it at Staples. You shove that on the part and it takes off any lint or dirt or stuff. I actually use this stuff a lot. All right. And I think, so the other thing I checked, it's kind of hard to see because I can't hold the part and move it. The front of the thread, the very first thread there, why are you so blurry? I've added a Higby thread to it. So I'm using a grooving tool to cut the first thread down and fade it out across the top of the thread so that it creates this like beautiful transition and not a sharp first thread. And it's the kind of thing you can only see under the microscope. You can't see it. You can barely see it with your eyeball. See if I can fake it. There you go. So that's called a blunt start thread or a Higby thread. And man, does it ever create a beautiful, beautiful thread. I love it. I even checked the tip of the part right there to make sure that there's no little nub, meaning that the turning tool is too high or too low. So there's lots of little stuff that goes into this part. All kinds of stuff we work on. And this is only one tiny little part, like literally tiny, of the entire knife assembly. And we put this much care and dedication into everything that we do. So yeah, that's pretty much the process of making this from, this doesn't even count the programming or anything like that, but setting up the machine, running it, dialing it, checking it. Usually it'll take me a couple parts to get the tolerances bang on. And then in the first half hour of the machine running, I gotta watch the tolerances, make sure that they don't drift a little bit. But once the machine's warm, you're changing like tenths. You're changing like 1/10 every now and then, just because you can. So that's really fun. So yeah, it's fun. I like making my own stuff. It's very cool, it's challenging, it's fun. And once you anodize the screws, like my knife has, I call it the Rastafarian screws because there's kind of one of every color. And a lot of people actually really like that. But because they're titanium, we can anodize them, give that pop of color. And yeah, I just love it. I love it. All right, guys, thanks for watching. Stay tuned for a lot more machinist type videos.